Okay guys, question 2. A constant force F pulls a 50 kg block at a constant speed. Constant speed, if you see constant speed or constant velocity, it means that F net is 0 because acceleration is 0. That's very important to know. Over a rough a rough horizontal surface. When they tell you about a rough surface, they're telling that frictional force is present, but they are not specifying which type of frictional force are they talking about, because we have two types of frictional forces, the kinetic and the static frictional force. But we'll find it as we are continuing with reading. A constant force F pulls a 50 kg block at a constant speed over a rough horizontal surface AB, as shown in the diagram below. The coefficient of kinetic friction between the block and the surface is 0.4. Meaning that since they say that the coefficient of kinetic friction between the block, this is the block, right, the 50 kg block, and the surface is 0.4. So as we discovered that here, this tells us that we have frictional force, but what type of frictional force is Fk? But if they were talking about the coefficient of static frictional force, we would say that the frictional force that is present here, or the frictional force that they are referring to, is Fs, or static frictional force. So 2.1. they want us to draw what? The free body diagram. We know that the free body diagram is represented by what? By a dot, showing arrows pointing away from the dot. Now the value of the normal force exists. Why? Because the object is in contact with the surface. If you don't understand that, make sure that you go to our lesson where we're explaining all the forces in Newton's second law. So you show F, or Fa, as it is shown on the diagram, but you do not show the angle. Now we have the value of Fk opposing what? The motion. They said 4 marks, therefore we can get that 4 marks. 1, 2, 3, and 4. If they say 5 marks, it means that the forces that you must show on your free body diagram or a force diagram is what? Like you must show 5 forces. 2.2. What about 2.2? State Newton's first law of motion in words. States that a body will remain in rest or uniform velocity unless it is acted upon by an unbalanced force. So I won't write it. 2.3. Calculate force F. Okay, this is the formula that we are using. F net equals ma. Not your mom, but M is, or M stands for mass and acceleration stands for A. A stands for acceleration. Okay, I don't know what you're laughing for. What are you laughing? Why are you laughing? Okay. On the F net part, we know that we substitute forces that are horizontal to the direction of motion, or horizontal forces from our free body diagram. Therefore, you must know that whenever the force applied is pulled at an angle, you must resolve components, or you must resolve into components. This is what you do. This is Fax, then this becomes Fay. This is very, very essential, guys. Now we don't have one force that is horizontal, but we have two forces, which is minus Fk since it is pointing in the westerly direction, plus Fax since it is pointing in the easterly direction, equals 0. Then do not forget that you write F net equals 0 before you can substitute. Why? Because they talked about constant speed. Even if they talked about constant velocity, F net becomes 0. But constant acceleration, no. F net cannot be 0. Okay, the value of Fk. What's the value of Fk? We don't have the value of Fk. We only have the coefficient of kinetic friction, meaning that the first thing that we must do, you must calculate the value of the normal force. This is the formula to calculate the value of the normal force, or this is the formula that we can use to calculate the value of mu k. But now we can't have the value of Fk. We just have the value of mu k, not the value of the normal force. Therefore, we have to calculate the value of Fn first, so that we can substitute it here, which is Fg minus Fa sine theta. Fg minus Fa sine theta. What's the value of mg? Which is mg minus Fa sine of theta. M is 5, G is 9.8. Okay, let me just take this thing and write it here so that you can, but make sure that you start by writing this first. Just I want us to see. It's Fn equals mg minus Fa sine of theta. Mg is 50. It's 50 multiplied by 9.8 minus Fa sine of 20. Then what's 50 multiplied by 9.8, which is 490, minus sine 20, which is 0.34 Fa. So this becomes what? The value of the normal force. So this is the value of the normal force. All right, but make sure that you start by writing all of this because we must substitute it there. Now, where does Fk? We must put the value of Fk. We don't have it yet, but we can multiply the mu k, which is 0.4. 0.4 multiplied by the value of the normal force, which is 490 minus 0.34 Fa, right? Therefore, we multiply this and this because this thing is like this. Okay, 0.4 multiplied by 490, you're going to get 196 minus 0.4 multiplied by that, 0.4 multiplied by negative 0.34, you're going to get negative 0.136 Fa. So this is the value of mu k. So when you substitute it here, this one would become, and this is the value of Fk, not mu k, it will become negative 196 plus 0.136 plus Fa cos of 20 equals 0. Therefore, you can transpose this to go to the to the right. Yes, what else? This is Fa, do not forget that. Sorry guys, because it comes from this, right? So negative, okay, we'll take this negative to go on the right. Therefore we'll have 0.1 like this, 0.136 plus cos 20, because these are like terms, Fa and Fa. We're going to have 1.08 equals, or 0.8 Fa equals 196. Then we can divide both sides by 0.18. 1.08. 196 divided by 1.08. Therefore, we'll have the value of Fa as 181.48 Newton. This is our answer. But you start here, then you come here, you end here. Sorry for this for the way that I wrote this thing, but I hope you understand it. Okay, let's continue. Okay, what else? 2.5, they want us to calculate what? The frictional force. The value of the frictional force. That's 2.5. is it 2.5? No, 2.4. The value of the normal force, Fn equals Fg minus Fa sine of theta. We know that here, this is what we are going to write. The value of the normal force, okay, we have the value of Fa, so here it will be 490, because this is the same as what we were finding here. 490 minus 0.34 Fa. Now the value of Fa is what? Is 181.48. 490 minus 0.34 multiplied by 181.48. The value of the normal force becomes 428.30 Newton. You round it off, right? Okay, 2.5. They want us to calculate the value of the frictional force. The value of the frictional force. Okay, we can use this formula. It's Fk equals mu k. Fk equals mu k multiplied by the normal force. Therefore, we must find the value of Fk. We have the value of mu k, which is 0.4. Therefore, 0.4 multiplied by the value of the normal force, which is 428.30. Then you can just punch that in your calculator. 0.4 multiplied by 428.30. Then you will have your answer as 171.32. The value of Fk is 171.32 newtons. Let me just fix my stand. Okay, I don't know if you guys understand this. Okay, now they want us 3.6. How is it 2? Then they're supposed to write 2.6, not 3.6. Okay. This is actually, you must give a reason. So the same constant force F is now applied on the block over the same rough horizontal surface at as before, but in the direction shown below. Then give a reason why the block will move slower than before. So make sure that you write this answer, because make sure that you understand this, what's written here. Then you come back here and try to answer 2.6 or 3.6. Then leave its answer on the comment section, writing question 2, 2.6, then you give the reason, because this is very, very important, guys. I hope we understood each other here. Let's do the next one.